All right, let's talk about a new type of equilibrium, something we're going to call the solubility product. Solubility product just describes the equilibrium of saturated solutions of ionic solids. It's got a small subscript of Sp just because it's just a defined type of system. Now, when we think about ionic solids dissolving, we have to remember that ions are positively and negatively charged, and in water, the slightly negative end of the oxygen will surround the positive ions. The slightly positive ends of the hydrogens will surround the negative ions. But in reality, what's going on is as the water is attracting those ions away from the solid, some of those ions could be going back onto the solid. And so we can get this equilibrium where the number of ions dissociating and the number of ions reforming the solid are happening at the same rate, and now we have an equilibrium. And this equilibrium, for example, would exist in something like silver chloride. Silver chloride isn't very soluble, and it can just be written as the silver chloride solid dissociating into its ions, the silver plus ion and the chloride negative ion. And we would write the KSP just like any other K, where we write the products over the reactants. However, here the silver chloride reactant is a solid, which we don't consider in equilibrium. So the KSP is just the product of all of the products and with any coefficients. In this case, the coefficients are both 1. So it's nice and simple. So really starting off, you have to be able to think about what salts are, and again, going back to that nomenclature. So here's a little bit of practice with it. As with all practice, you can kind of pause it and go, but we'll just kind of go through these one by one. So the first one is strontium carbonate. So strontium is Sr, it's got a positive 2 charge. Carbonate is CO3 2 minus. So together we're going to get this formula of SrCO3. And from that I can take it and write my equilibrium equation and my expression for it. And that's just going to be the strontium carbonate solid breaking into the Sr plus 2 aqueous, the carbonate aqueous, and then my KSP is nice and simple. The second one here is magnesium hydroxide, MgOH. The Mg has a positive 2. The OH on the hydroxide has a minus 1. So when I put these together to balance the charges, I'm going to get magnesium hydroxide. Writing the equation, I'll see the magnesium hydroxide solid breaks apart into the magnesium plus 2. The hydroxide has a minus 1. There are 2 of them because every time this dissociates, it's going to produce 2 hydroxides. So in the KSP, we're going to see that square on the hydroxide because its coefficient is a 2. Calcium phosphate. Calcium is a positive 2 ion. Phosphate is PO4 with a minus 3 charge on it. So we're going to get Ca3, PO4, 2. A little complicated, but nice and easy once again. We get Ca3, PO4, 2 breaking up into 3 calcium positive 2s and 2 phosphates. I have a typo there. That should be a 2 phosphates. And over here, we do have that square. Let me go back and fix that real quick. So that's going to be a 2. And there we go. That's nice and fixed. And that's really all there is to writing KSP.